on these, you can use Desmos to check your work to see if you have the equivalent equation in standard form or factored form after you've distributed or factored your equation to get the other, and to see if you identified the x-intercepts, y-intercept, and the vertex and the overall shape of the parabola correctly. So I'll go over a couple of these just to show this process if you're having a hard time getting started or if you're trying to check your work. But I won't be going over all of them because you can check those in Desmos. I'll be talking more just about the process, the thought process that you're using. So I'm going to look at this one over here, the x minus 6, x plus 4. Over here for a first one, just because it has a little bit more complexity to it because it has different signs and it's not centered on the y-axis or anything like that. So first of all, the x-intercepts are given by the m and n values. It's just these numbers that are in our factored form, the minus 4, or sorry, the minus 6 and the plus 4. So remember, the x-intercepts are the x values that make y equal to 0. And those x values that make that happen are the x values that make each expression equal to 0, and there are two of them. So first of all, you can tell with this one, if x was positive 6, 6 minus 6 would be 0. It doesn't matter that it makes our other expression 6 plus 4, which is 10. 0 times 10 is going to be 0. So we know one of our x-intercepts is going to be at 6, 0. Our other x-intercept would be at negative 4, because if x was negative 4, negative 4 plus 4 is 0. On the other expression, it would be negative 4 minus 6, which is negative 10. But remember, if the expression on the right has a value of 0, it doesn't matter what the expression on the left is. 0 times anything is 0. So our other x-intercept is negative 4, 0. Now to get the y-intercept in the vertex, we'll change this to standard form. Although actually you could find the vertex now using these x-intercepts, remember, but we'll get to that. We'll get to that later. So the next thing we want to do is we want to use FOIL to do our distributing. So I'm going to do x times x is x squared. X times 4 is 4x. Negative 6 times x is negative 6x. And negative 6 times negative 4 is negative 24. So when I really simplify this down, though, I get x squared minus 2x minus 24. So the minus 2x is 4x minus 6x. That's combining like terms to get 4 minus 6 is negative 2. So remember, now we know that if in this form x is 0, y will equal negative 24. That's your c value or your y-intercept. So your y-intercept is going to be 0, negative 24. Next, we want to find the vertex. So remember, the vertex is equally spaced between the two x-intercepts. Our two x-intercepts are 6 and negative 4. Sometimes it helps to do a sketch of these, actually. Let's see. I'm going to leave room so I can have that y-intercept at negative 24. I'll just center it. Okay. So if we have intercepts at 6 and negative 4, let's say 6 is here and negative 4 is there, and we have a y-intercept at negative 24, let's just say it's way down there, you can start getting a picture in your head of where the vertex might be. Notice the two x-intercepts aren't perfectly centered on the y-axis, they're shifted to the right a little bit. So if I was to draw this parabola, I bet you it would be something kind of like that. That's really, really messy. I'm gonna try that again. Something like that. Our vertex is going to be shifted just a little bit to the right. So the midpoint between 6 and negative 4, the difference between those is 10 units, between 6 and negative 4. It means if I go from negative 4 and I add 5, if I go from 6 and I subtract 5, I'm going to have an axis of symmetry going through there, and that's going to be at x equals 1. So I know that the x value of my vertex is 1. Now I just need to substitute that into my equation to calculate the y value. So y would equal 1 squared minus 2 times 1 minus 24. So that would be 1 minus 2 minus 24, would be negative 25. And that makes sense. It's just to the right and below that y-intercept. If you imagine if it was centered on the y-axis, but then you shift it just over and down to the right just a little bit, it's going to be just below negative 24, just to the right of the y-axis. So we have a vertex at 1, negative 25. So put both of those equations into Desmos, and you can see that they match up. And if not, you can see which parts don't match up, so you can maybe get an idea of what went wrong if you don't have a match, if you don't have the right characteristics. But it does help to double check your work as you go, to sketch out what the pieces of the parabola look like, to see if they fit together to make a parabola. So the problems that are a little bit tougher tend to be the factoring problems. Just like any operation, usually one way is kind of easy and algorithmic, and the other way takes a little bit of head scratching. Factoring is definitely that way. So follow this process. So first of all, we know that a quadratic like this is going to factor into two binomials. We know that it's going to have two regular x's. There isn't going to be a negative x. There isn't going to be a 2x. Again, those will be extensions in next week's activities if you want to make these a little bit more challenging. So it's positive x times positive x gives us that x squared. Now, we know that we're looking for a factor pair of negative 24. So if it's a factor pair with a product of negative 24, it has to be a positive and a negative number. A positive times a negative would give us a negative c value, that negative 24. So we know they have to have different signs. And we know these two numbers have to be a factor pair of 24. So sometimes you have to do a little bit of tinkering. So for example, you could do 2 and 12. They have that factor pair has a product of negative 24. But when you distribute that, notice 2 plus negative 12 ends up being negative 10. It doesn't have a sum of negative 5. So if you distributed this in factored form, you wouldn't get x squared minus 5x minus 24. So start thinking, what would be a factor pair of 24 that adds up to negative 5? So sometimes what helps to do is actually list them out. So it could be 1 and 24, 2 and 12. It could be 3 and 8. It could be 4 and 6. So when you look at those, remember you can have positive or negative versions. When you look at those, you should say, wait a minute, 3 and 8. They have a difference of 5. So notice if I put in 8 and 3, that wouldn't quite work. Positive 8 minus 3 would give us positive 5. So notice these do take a little bit of tinkering, especially until you get a good feel for them. And negative 8 and positive 3. So positive 3 and negative 8 add up to negative 5. And if you distributed this using FOIL, it would take you back to x squared minus 5x plus 24. So now we can describe some of those characteristics of our parabola and get an idea of what this pattern looks like. So first of all, the x-intercepts would have to be negative 3 and positive 8. Negative 3, 0, and 8, 0. So those are the x values that make each expression equal to 0 and thus make y equal to 0. The y-intercept is negative 24, so 0, negative 24. And then to find the vertex, we need to know the x value of the vertex, so we can put that into our equation and calculate the y value of the vertex. I'm going to do a sketch again. So we have intercepts at 3 and negative 8. I'm just kind of eyeballing where these are. They don't have to be exact. And we have a y-intercept at negative 24, so it'd be somewhere way down here. So now you can picture a parabola starting out centered on the y-axis, but you can tell it's been shifted to the left. So picture a curve that goes down. Not too bad. So now we want to figure out what this vertex would be. So we know the x value of it must be, let me think, the halfway point between 3 and 8. 3 and 8 are 11 units apart. So if you were to go from -8 up 5.5, that's half of 11, or go from 3 down 5.5, that would put us right in the middle. So -8 plus 5.5 should be 2.5. That would be -2.5. We're over there in the left quadrant. Comma y. So remember, all you need to do now to find the y value of the vertex is substitute that -2.5 in. So, and you can actually put it into either form. You could put it into factored form, or you could put it in standard form. For some reason, I tend to put it into standard form. Doesn't mean you couldn't go the other way. But what you're going to do is you're going to do -2.5 squared minus 5 times 2.5 minus 24, and you'll get the y value of your vertex. And you know it should be something that is below, so deeper into the negatives from -24. So probably somewhere near -25, like the other problem that I looked at, but not exactly. Put that into Desmos, double check your work. So as you go on, that's the process you're going to follow for each of these. Most of these, I haven't thrown in any really complicated ones. I know these are definitely not simple, but as a challenge, there'll be some more complicated ones. Be careful, there are some other forms like this. Now, this is actually standard form. Just remember when you see a problem like this, that it's inferred that there is a plus 0 there. And so when you're factoring this one, you can think, okay, so this must, if you went like this and tried to factor this, you're not going to get two binomials. One of them is just going to be, you have to have a 0 in there, like x plus 0, because 0 times whatever is over here has to be 0. You know you're going to have two x's. And so now you're thinking, well, what factor pair of, it's kind of hard to say, what factor pair of 0 adds up to 3? So you're really just looking for two numbers that add up to 3, and they would be 3 and 0. You can also look at this one and realize that you can actually just factor out an x. So this one here on the left, just that x, is the same as writing x plus 0. You don't have to write the plus 0. So when you see one that doesn't have a c value, that means that it goes through the origin. When x is 0, y is 0. And it means when you factor it, you're not going to get two binomials. You're going to get a monomial with one term and a binomial. So be careful with those. There are some slight variations to it, but that's probably the trickiest one just because